Hello, class. Today I want to work through our midterm review. Majority of the questions are going to be related to, well, modules 1 and 2, and then just a few from the first part of module 3. You'll notice that the review, I'm about to share it. It'll start off with module 1, with it being terminology, and then it'll kind of pretty much go in order. Now, when you work the review, if you work it numerous times, they may scramble the questions, so it may not be in this exact order when you work it. But you all should have gotten a copy of these review questions if you came to class this past week, the week before spring break. If you came to class, then you all got a copy of this. But again, it's just a review. You all have access to the review. You can work it an unlimited number of times to prepare for the midterm. But I wanted to create a video just where I'm working through it. So I'm going to start off with sharing my screen. Okay. And I'll zoom in and out as needed. But we'll start off with the first three questions, as you can see, are related to um, Module 1, terminology. Number one, oh, and also the solutions are at the back of this for those of you that do have this copy. So number one is just asking, how's a sample related to a population? Very rarely do we have access to an entire population, so we use a sample, which is just a subset or smaller data set pulled from the population. So a sample is a subset of a population. That answer would be C. Number two, why is a sample used more often than a population? That is because it's usually impossible to count the entire population. We usually don't have access to the entire population. So that would be A. Okay. Number three, what are the two main branches of statistics? There are two types, and we've actually been focusing on the first type up until this point, which has been descriptive statistics. The other type, or the other branch, is inferential statistics. So that would be that first bullet there, that first dot that we'll select. Descriptive, remember, is ways to display data, finding measurable quantities, finding mean, median, mode, finding standard deviation, displaying data in a bar graph or in a frequency distribution. That is all descriptive statistics. And then we use descriptive statistics to then make educated summaries or decisions, educated guesses in a sense, using inferential statistics. Okay, moving on. Still in module 1, look at number 4. It says use the Venn diagram to identify the population and the sample. Now the picture got cut a little bit, but this is parties of registered voters. That's the population. And then within the population, you've got a subset, okay, or sample in this circle. And then even this is a sample as well, but we're going to be focused on naming the sample that is within the oval, that's in the gray oval. So the actual population is parties of registered voters, okay, the parties of registered voters, keyword parties. You don't want to accidentally choose number because that says parties. So that would be A. And then choosing a sample or choose the correct description of the sample. This sample in the oval is the parties of registered voters who voted in the last election. So that would be D. Okay. Out here in the sample space, because this whole box represents the whole population. So you got a sample here of parties of the registered voters who voted. And then out here, outside of this oval, the party of registered voters who did not vote. But we're interested in that sample. Okay. Number 5 is giving us some years that a particular team won the World Series, and we're asked to determine the level of measurement. So keep in mind there are 4 levels of measurement. Nominal is the lowest level, okay? Then you've got ordinal. So nominal is the lowest. Then you've got one level above that would be ordinal. Then you have interval. And then you have ratio being the highest. So nominal is just categorical. Ordinal is usually still categorical, but it's put in order. Interval is typically data that is numerical. It can be ordered, and you can find differences among the data. Ratio, you can do everything that interval can do, but in addition to finding differences, you can also find multiples. And then also zero is an inherent zero, okay, or not an inherent zero, I'm sorry. So in this case, we're talking about the years a particular team won the World Series. We can't find ratios of years. We can't find multiples of years. Okay, so first of all, it's numerical. Okay, so it can't be nominal right away. Um, but in addition to it being numerical, it's in order from oldest victory to most recent. It's put in order, okay? But beyond that, we can also find differences among the data. We can determine how many years passed between their first victory and their second, for example. So that would be interval. That would be level C, okay? Moving on. Look at number 6. It says the top 5 books on the bestseller list last year are shown below. So these are just some categorical data. They're names of books, but not only are they just the description, the name, they're put in order, top 5. So it takes it past the nominal level and brings it to ordinal. The data can be arranged in order, but you can't calculate any differences, again, because they're not numerical anyway. So that would be ordinal. Okay. Number 7 says, what is the difference between an observational study and an experiment? So an observational study, no treatment is applied. You're literally a fly in the room, fly on the wall, just observing um, their natural behavior and their natural environment, whatever the uh, parties of the experiment are. So let's just figure out, let's read through these. Here's A, let's read A. In an experiment, a treatment is applied, that's true, is applied to part of a population and responses are observed. In an observational study, a researcher measures characteristics of interest of a part of a population but does not change existing conditions. I'm going to say A is the answer, but let's read B and see why B doesn't work. It says in an experiment, a treatment is applied to an entire population. That's the issue right away with that. You do not apply an experiment to the entire population. You have a control group and you have a treatment group. So the treatment is applied to part of the population, the treatment group. So it's not B. C, an experiment, a researcher measures characteristics but does not change existing conditions. Nope. An experiment, a treatment is applied. So you are changing existing conditions. So it can't be C. D, in an experiment, a researcher measures characteristics of interest of an entire population but does not change. Again, that's not right. It cannot be D. That does not describe an experiment. So the answer is definitely A. Okay. Moving on. Again, starting off with just heavy terminology here. And we've seen all of these questions. That's the good thing. Okay. These really, none of these should be surprises. You've seen them, whether it be the homework, self-check, or even the exam. All of these have actually shown up in the homework back in module 1.1 to be exact. Here it says identify the sampling technique used and discuss potential sources of bias. So let's see. Questioning students as they leave a university dorm, a researcher asked 373 students about their eating habits. So questioning students as they leave a university dorm, okay? That is some convenience of location because he's only questioning those students who are leaving that dorm. Anybody that doesn't go to that dorm that day can't be polled, can't be questioned. So this would be a convenient sample because students are chosen due to the convenience of location, okay? And anytime you're sampling, you do have potential sources of bias. The only way to, without a doubt, eliminate bias is to use the entire population, but that's not feasible. In a perfect world, it would be, but realistically, we don't have access to the whole population. So there will always be a source of bias. So D can't be the answer, okay? Let's see. A says university students may not be representative of all people in their age group. No, that's not an issue because we're told right here to assume the population of interest is the student body at a university. So them not being representative of people in their age group, that can't be right because they're the population. So it's not A. B, the sample only consists of members of the population that are easy to get. Yes, convenient sampling itself can cause bias because of the definition of convenience. You're using only those members of the population that are easy to access. So B is definitely a potential source of bias. What about C? Because of the personal nature of the questions, students may not answer honestly. Yeah, you may have students who may not answer honestly. They may not want to reveal their eating habits to a stranger. So that could lead to bias as well. B and C would be the answer there. B and C. Look at number 9. Number 9 says identify sampling techniques used and discuss potential sources of bias. After a flood, a disaster area is divided. So we're talking about groups here. We're dividing the area into 150 equal grids. So of that total 150, 30 of them are selected, okay? And then every occupied household in that 30 will be interviewed. So when you are not using, or when you don't have every group, because you're dividing it into grids, when you don't have every grid or group represented in your population, in your sample, then that is cluster, okay? When every group or grid for this one is represented, it's stratified. So we know right away we've got 150 grids, but we're only choosing 30 of them. We're only selecting 30 of them. So this is going to be cluster. Is it A or B? That's the question. A says cluster sampling is used. Since the disaster area is divided into grids, some of those grids are selected and everyone in those grids is interviewed. Yes, that is correct. That is the definition of cluster. B says cluster in the beginning, but then it starts talking about a random sample taken from each grid. So that's not the definition of cluster, okay? And again, because you're sampling, you do have potential sources of bias. Let's see what they may be. A, certain grids may have been much more severely damaged than others. The grids that are selected may not be representative in terms of damage. Absolutely. It's possible that the grids that you selected are way more damaged than the majority. And so it's skewing our, I guess, our overall data. Let's read B. The sample only consists of grids that are easy to get. No, that's convenience. That's the definition of convenience. C. Certain grids may have been much more severely damaged than others. Yes. Severely damaged grids may have fewer occupied households. Absolutely. So if you're selecting severely damaged grids, it's probably really highly likely that a lot of people are not still living there. They've had to vacate. So yes, that is a potential source of bias as well. A and C. And remember when you're sampling, there's always source of bias, so it would never be D. Okay, moving on. Another problem related to sampling technique. It says soybeans are planted on a 54-acre field. The field is divided into 1-acre subplots. So again, we're talking about groups, dividing the total field into 54 subplots, so 54 groups. Then it says a sample is taken from each subplot. So that makes this stratified. When each subplot or each smaller group is represented in your sample, that is a stratified sample. Since the field is divided into subplots and a random sample is taken from each subplot. Okay? Again, you will have bias automatically when you are sampling. So let's see. A says the sample only consists of soybean plants that are easiest to reach. No, that's convenience. B says it is possible that due to sampling error, the sample will not be representative. No, there's no issue with a stratified sample. You're literally dividing it into groups and you're pulling some from every group. So there's no issue with that. C, certain subplots may have more or fewer soybean plants than others. Samples from these subplots may bias the overall sample. There is the bias, potential source of bias. Okay. Number 11, determine if the survey question is biased. If it is, suggest a better wording. The question, why is eating vegetables good for you? So, yes, that question is biased. It's leading you, it's guiding you towards a specific answer. Like it's basically telling you eating vegetables is good for you. Instead, it should ask, what do you think about eating vegetables? Okay, so it's very leading. So, the question is definitely biased. And I think the best way to word that question would be, how do you think eating vegetables affects your health? That would be better. Okay. And again, the solutions are at the back. Okay. Number 12, determine whether the statement is true or false. In a frequency distribution, the class width is the distance between the lower and upper limits of a class. No, the class width is the distance between the lower or the upper limits of consecutive classes. So in other words, you can look at the lower limits of consecutive classes and figure out the class width, or you can look at the upper limits of consecutive classes, but you don't mix them up. You look at the lower or the upper. So that is false, and instead we are going to select A here. In a frequency distribution, the class width is the distance between the lower or upper limits of consecutive classes. Okay. And I'm sure we're going to have to do a frequency distribution in just a second anyway. So we're in 1.2 now with that first question. The first 11 questions were pertaining to 1.1. 1.1, remember, is the heavy terminology section. So yeah, now we're getting into the frequency distribution properties, things that we're going to try to find. So here it says use the given minimum and maximum data entries and the number of classes to find the class width, the lower class limits, and the upper class limits. So the first thing I'm going to do is get the class width. And remember, you always round the class width up. It is the max minus the min divided by the number of classes that you're told to use. And in this case, we have a max of 93, a min of 13, and we're told to use 6 classes. So we have 93 minus 13 divided by 6. So you get that difference, and then you divide the difference by 6. So 13.333, we're going to round that up to make that 14. You always round up the class width to the next whole number. Okay, always round up. So yes, I know mathematically 13.3 is closer to 13, but when it comes to class width, no matter how much that decimal amount is, we round it up to the next whole number. So even if that had been like 13.05, we still would have made it 14. You round it up. Okay, now to get the class limits, let's start with the lower. We start with the minimum data value, which is 13. And then from there, we add the class width to get the next one. So we'll say 13 plus 14, adding the class width to get the next limit. That's 27, then 27 plus 14. It's 41, plus 14 again, 55. And you might be able to point out which one it is by looking now. 13, 27, 41. That's the only one that has those first 4 values correct. And of course, I keep on going. That will give me 69 when I add the 14 again. And then when I add it again. So it is C. 13, 27, 41, 55, 69, 83. Okay, that's the lower. Now, to get the upper, you got to have a starting point. Now, here with the lower, we always just start with the minimum data entry. The minimum number in the data set was 13. That's what we start our lower class limits with, the minimum data entry. Now, with the upper class limits, I need you to think about it, okay? It helps if you draw these vertically. That's why I did this here. My classes have to consecutively follow each other, okay? So if class number 2 begins at 27, class 1 had to end right before that at 26. So that's my first upper class limit, 26, okay? And then I'll add 14 to that. And I'll just keep adding until I get all of them. So the next one will be 40, and that should make sense because class number 3 starts at 41. So these are the upper. Then I'll add 14 again, 54, 14 again, 68, because as you can see, 54, 55 will follow that, 68, 69 will follow that. So these are the upper limits, 54, 68, 82, and then lastly, 96. Okay, so that would be for number 13, that would be what, C? 2640, yeah. Okay. 14, it looks like we're doing basically this again. The only difference is they don't give us the max, but they give us the range. Okay, so if they gave me the max, I would literally just say class width is max minus the min divided by the number of classes. Okay, that's what I essentially would say. But they don't give me the max. What they give me is the range. Well, max minus min is the range of the data. So essentially, that numerator, we can just say that's the range, and I'm going to divide that by the number of classes. So the range, I've got 125, and I'm told to use 8 classes. So 125 divided by 8 gives me a range of, let's see, a class width, I'm sorry, gives me a class width of 15.625. So we're going to make that 16. 15.625. We're going to round that to 16. So the class width is 16. Now, I start my lower limits. And again, I tend to prefer to see them written vertically, if that helps. I start my lower class limit, my first one, with the minimum data entry. And then I'll just keep adding the class width every time. So the minimum data entry was 14. Then I'll say 14 plus 16. And I'll get 30. Then I'll say 30 plus 6 plus 16. I'll get 46. Then 46 plus 16, I'll get 62, 78, 94, 110, 126. Okay? So 14, 30, 46, 62, 78, 94, 110, 126. I'm going to do the same thing with the uppers, but I have to have my starting point. I have to have my first class upper limit. If class 2 begins at 30, then class 1 had to end right before that at 29. Okay? So I'll have 29, then I'll add 16. That'll give me 45, 61, 77, 93, 109, 125, and then 141. Okay? Again, we have done these before. The main thing, the difference between 13 and 14 is that they did not give me the max. So instead of finding the max minus the min, I said, well, that by definition is just the range. They did give me the range. Okay? And then I just added the class width again here, 45, 61, 77, 93, 109, 125, 141. Okay? Keeping it moving. Trying to keep the video not from running too long. Okay, looking at number 15, we are basically just looking at this histogram and answering some questions about it. So part A says there are blank classes. Each bar represents a class. So 1, 2, 3, 4, 5, 6, 7 classes. Okay. The least frequency. Now this is where it'll be a little tricky on this paper. But remember on the computer, you can use the pop-out window. You can make it bigger. But when I clicked on the pop-out window, I was able to see that, yes, this is definitely the class with the lowest frequency, and it's about 10, because these little tick marks in between these will be in measurements of 10 units. So the least frequency is about 10. The greatest frequency looks like it's this one. And again, when you use the pop-out window to make it bigger, you can see the scale, and that's about at like 270. And then the class width, basically look at each class. Each class is centered at its midpoint, or each bar. Each bar represents a class. So each bar is centered at the midpoint. These bars are the exact same width apart, same distance apart. So we go from 34.5 to 44.5, 54.5, 64.5. We are increasing every time with these midpoints by 10. So that is the class width, 10. And then lastly, it says, what pattern does the histogram show? Well, it's going to end up being D. And again, we've seen this problem where about half of the employee salaries are between, basically, I used the process of elimination. Okay. You look at the bars and you see that, like, for example, it says about half of the employee salaries are between 70,000. So 70,000 would be about right here, and 89,000, which would be about right here. And that would be a no for me. That is most definitely not about half of all the employees, because this bar is extremely short. And you got these two tall ones here, and that short one, or that one next to that one, is not that much shorter than this one. So A just would make sense. It ends up being D. About half of the employees make between 50, which is about right here, and 69, which is about right here, which are those two tallest bars. Okay. All right, that brings us to number 16. Now, this is the one that may take a little bit more time. Okay, I'm going to try to get through it pretty swiftly. So looking at this, it says the data represents the time in minutes spent reading a political blog in a day. We have 1, 2, 3, 4 columns of 1, 2, 3, 4 values. So I am not certain if that's right. I think some data was cut off because I'm looking at this. Oh man, that's unfortunate. Oh, how am I going to determine this if my data is cut off? Hmm. Mm-mm-mm. Dang it. My data was cut off on this problem. So, hmm, and I have no way of, I mean, I've got the solutions to the problem, but I need to actually know what that missing column is. It's supposed to be 20 data values, and it got cut off. Let me see if I've got another one that may be printed better. I don't think I do. Let's see here. I hope. And I don't. Okay, well, I have worked this problem many, many times. Um, I have a video for this problem in 1.1. Please refer to it if you struggle still with this one. Remember my recommendation when working this problem is to find all the lower limits and then find all the upper limits. Okay. Um, One thing I believe we should be able to do is at least find the class width. And if nothing else, I think we can find the classes. I can do at least some of this problem. I can do as much as I can. Unfortunately, like I said, it got cut off. Um, But to get the class width, we're going to look at or determine what is the max and the min, and then we're going to divide by the number of classes that we're told to use. So I'm pretty certain that the max is 49 and the minimum is 0, okay? I am strongly believing that to be accurate. So I'm going to say max, even though I got some cut off that I don't see, I want to say that that is the max. So 49 minus 0, the minimum is 0, divided by how many classes? 5. So 49 divided by 5 gives us 9.8, which we're going to round up to 10. Okay, so my class width is 10. I start these are my lower limits here. These are my upper. Okay, I'm going to definitely do this part. It's going to be hard for me to do frequency because I don't know the column that's missing. I can't determine, what those values are, but I can at least do the hard part. To me, this is the hard part. The most important part is making sure that the lower limits and the upper limits are correct, okay? And then from there, you're partitioning the data values into each class. You're counting how many data values belong to the first class, or how many range between 0 being the first class lower limit, and we start with 0 because that is the minimum data entry. That is the minimum data value. Your first class lower limit should always start with the minimum data value from the set. Then you will add the class width to get the remaining lower limits. So class width is 10, so we're going to say 0 plus 10, that's 10. Okay. Then we'll say 10 plus 10, that gives me 20. 20 plus 10, I get 30. And then 30 plus 10, I get 40. Okay? Now, to get my upper limits, I have to have a starting point. Class number 2 began at 10, so class number 1 has to end right before that. Okay, if class 2 begins at 10, class 1 has to end right before that at 9. And then I'll add the class width every time to get the next upper limit, and then the next one, and so on. So 9 plus 10, I get 19, which should make sense because class 3 begins at 20. And then 19 plus 10, I'll get 29. 29 plus 10, I'll get 39. And then 39 plus 10, I'll get 49. Now, it just so happens that the last upper limit was also the max number in the data set. That does not have to work out like that, okay? Now, you will always start with the minimum data entry, but that does not mean you have to end with the max. It won't necessarily always be like that. This just worked out nicely. And then from there, you just go through the data set and determine how many belong to each class, okay? Like I said, I'm missing a column. I hate that this got cut off. I apologize, but there is a problem just like this in a video that I created for 1.2, section 1.2, okay? The midpoints would be the middle value of the data set. I can get those. That would be for the first one, 0 plus 9 divided by 2. So that would be 4.5 for the midpoint of that first class. You do not round midpoints. Do not round midpoints. Okay, then 10 plus 19 divided by 2, I get 14.5, because basically I'm just going to keep adding 10 if you think about it. So I can say 20 plus 29 divided by 2, I'll get 24.5, which I could have just said plus 10 to get it. Then I'll do it again, plus 10, 34.5, and then plus 10, 44.5. Okay? Now the other two, relative frequency, excuse me, that is the proportion of data values, the proportion or how many data values belong to each class. Excuse me. You would need to know the frequency and then take that frequency and divide it by the total. The total number of data values, you're supposed to have 20. Okay. So if this one, let's say, had a frequency of 3, then the relative frequency would be 3 out of 10. I'm sorry, 3 out of 20. If this frequency was, let's say, 2, the relative frequency for that class would be 2 out of 20. It is the frequency of a class out of the total frequency. And the total frequency is the total number of data values. Okay. So that would be the frequency divided by the sum of the frequencies. Okay. And then cumulative frequencies is where you take the frequency of a class and then all class frequencies before it and you add. Okay. These two columns are directly tied to this one. It's important that this one is correct in order for these two to be correct. Okay. And then finally, once you have the table completed, you'll be able to answer the question, which class has the greatest frequency? You'll do the lower limit to the upper limit, and then which class has the least frequency, the lower limit to the upper limit. Okay. Again, go back and watch the video for this problem out of in my 1.1 video, my 1.2 video, my section 1.2. All right. Moving on to number 17, it's asking us to write out the actual data entries from this dot plot. So these dots represent whole numbers and they're placed at their particular value that they're representing. There are 2 dots at 18. That means we have 2 data entries in the amount of 18. So 2 18s. We have 3 19s. We have 1, 2, 3, 4, 5 20s. 1, 2, 3, 4, 5 20s. 1 21. 2 22s. 1 23. 1 24. So that would be A. And then the maximum data entry would be 24, and the minimum would be 18. Okay. This one, again, we've seen this problem as well. We are asked to display the data in a Pareto chart. It's given as a circle graph. A Pareto chart is just a special bar graph where the bars are listed in descending order. So we're going to start with the one that has the highest percent. That would be summer, it looks like, at 36. Then we have spring, and we're using SP to represent spring. So summer, then spring, then it would be fall, and then winter. So that would be D. Looks like that would be D. Okay. And then it says describe the difference in how the pie chart and the Pareto chart show patterns. Well, the pie chart will show percentages as parts of a whole. The whole pie represents 100%. So these represent parts of the whole. The Pareto chart shows rankings because it's going from the greatest all the way down to the least. So that would be D. Okay. All right, moving on. This one is asking us to determine whether the following statement is true or false. If it is false, rewrite it as a true statement. It says the mean is the measure of central tendency most likely to be affected by an outlier. That is true. That statement is true. An outlier is a value that is far removed from the majority. So let's say you had pretty much all your data ranging from, let's say, anywhere from 1 to 20, and then you had 76, a data entry of 76. That 76 is going to skew that mean because remember, the mean is where you add up all the values and divide by the number of data entries you have. That 75 or 76 is going to make that mean appear higher than it actually is. So the mean is the one that's most likely affected by the outlier. That statement is true. Okay. Moving on, here we're asked to find the mean, then the median, and then the mode. And so I'm going to definitely use the calculator here. I am going to put the data into a list. I'm going to put in list 1. Remember how we do that? we press the stat key and I want to edit. So I just press enter to edit. Now I already have some stuff in there, so I'm going to clear this out. Clear, enter. I'm going to go over here. I'm going to press clear, enter. So in this one, I've got 9, 11, 12, 12, 9, 10. I've got 1, 2, 3, 4, 5, 6, 8. So 1, 2, 3, 4, 5, 6, and then I've got 9. So I should have 13 values. Okay. All right. Let's now get ready to get the mean, the median, and identify if we have a mode. So now we're going to press stat again, and we're going to go over calc. And this is one variable statistics because it's just single variable. There's no order pairs, so it's number 1. You do not have a frequency list, so just scroll on down to calculate. So your mean, when we round to 1 decimal, ends up being 9.2. So we select A, and we put in 9.2 in that box. And it says, does the mean represent center? Yes, the mean is always a measure of center, as is the median. Okay. To get the median, if you arrow down, if you scroll down or use this arrow, you'll see median right there. The median is 9. So I'm going to select A there and then put 9 in that box. And it says, does the median represent the center? Yes, it is a measure of center. The mean and the median, these questions will always be yes. Okay. Now, as far as mode, we have to look at the data value that is the most repeated. And if it is too far removed, if it's too low or too high, too far removed or too far away from the mean and the median, then we say it's not a measure of center. Okay. So we do have a mode and it happens to be 8. And you might be thinking, well, 8 is close to 9. It is, but not in a sense, not with this data set, because this data set doesn't range that wide anyway. It only ranges from 9 to 12, or sorry, 8 to 12. So in order for us to say the mode is a good measure of center, it needs to be pretty spot on with the mean and the median. So here we're going to say no, that the mode does not represent center. It's just simply the smallest data value. Okay, so we're going to say E here. The mode does not represent center. It's just one of the smallest data value. Okay. Again, we've done this problem. Moving on. Number 21, we're asked to find the weighted mean. Okay. So here you've got the scores for homework, quiz, project, final exam, and then how much each of these assignments counts towards your final grade, the percent towards the final grade. So we're going to change these to decimals. So 0.20, it was 20%, so it's 0.20, 0.10, 0.10, 0.35, 0.25. So we're going to take each of these, the weighted mean score is the sum of each x times its weight all over or divided by the sum of all the weights. So I'm literally going to say 82 times 0.2, 84 times 0.10, 98 times 0.10, 98 times 0.35, 88 times 0.25. I'm going to multiply those all together, and then I'm going to get the sum of all the weights. So if you want to see that written out in a new column, if I had room here, this is what I would do. I would call this X times W, where I'm multiplying each X times its weight or times its percent. So 82 times 0.2, 84 times 0.10, and you can show the 1 or not, or sorry, you can show the 0 or not. 0.2 is the same thing as 0.20. 0.1 is the same thing as 0.10, okay? 98 times 0.1, 98 times 0.35, and then 88 times 0.25. And again, I'm so out of room there. I'm sorry for that. So I'm going to get those products, and then I'll put all of that up here, just showing that I'm going to add all of them. So I'm going to say 82 times 0.2. I get 16.4 plus 84 times 0.10, I get 8.4 plus 98 times 0.10, I get 9.8 plus 98 times 0.35, I get 34.3, and then 88 times 0.25, and I get 22. And then that is going to be all over the sum of just the weights, which is 0.20 plus 0.10 plus 0.10, or just 0.1, plus 0.35 plus 0.25. So 16.4 plus 8.4 plus 9.8 plus 34.3 plus 22. I get 90.9. And then here on the bottom, that's added up all together to give you 1. So 90.9 divided by 1 is 90.9. And it says rounded 2 decimals, so if you show the 0 or not, it'll take it either way. But I'll go ahead and put it in since it says 2. Okay. All right, number 22, I'm going to also use the calculator for this one. It says the numbers of regular season wins for 10 football teams in a given season are given below. Determine the range, the mean, that's variance, standard deviation, and standard deviation of the population. So it is a population, okay? So range is just the max minus min. The range I have to get, okay? You can't get the range from the calculator. The population mean, that's going to be called mu, but from the calculator, I'm going to use X bar. Okay? X bar by default is the mean, whether it's a population or a sample. And the reason is because even though we give it a different name, we call it mean mu, it's a population, it's still calculated the exact same as X bar. So the calculator just uses X bar. All right, then you got the population variance, that is sigma squared. And then the population standard deviation, that's sigma. So I'm going to put the data into my calculator. Let's see what we've got here. Let's press stat and let's edit. I need to clear out list 1, so I'm going to go up to the list name and press clear enter. Then I've got 2, 7, 15, 4, 12, 8, 14, 9, 3, 10. Okay. Let's go ahead and get our information. Let's press stat now. We're ready to calculate now. Let's go over to calc, and we're still using number 1. Go on down to calc. So the mean, well, let's go ahead and get the range. The range is the max minus the min. So what, 15 minus 2? So that's 13. Okay. Nothing else to do there. Now, the population mean, remember I said we're going to let that be called X bar from the calculator. They're calculated the same. That's the mean. X bar is what we're going to call it. That's what we're going to use from the calculator. So the mean rounded to 1 decimal is 8.4. Basically, we just rewrite that as is. It's already rounded to 1 decimal. All right, then we're looking for the population variance. We do not see sigma squared, but we do see sigma. So I'm going to write sigma. I'm going to write that down. Sigma sub x, sigma, is 4.270831301. And I'm going to square that so that I can get the variance. Okay. Now I wrote it down because when I start typing on the computer to square it, that's going to vanish. So I wrote the decimal down. Remember, I'm using sigma because it's the population. S is also the standard deviation, but it's for a sample. I have a population. So I'm typing 4.270831301. I'm sorry, square. I didn't square it yet. Let's square it. So 18.24, it says round to the nearest 10, so that's just going to be 18.2. So we take that number 4.270831301, and I tend to use every decimal when I'm still calculating the value because I'll round it at the end. Okay. And then lastly, the population standard deviation. Well, that is the standard deviation, the population standard deviation. We just need to round it to the tenths, to the first decimal. So it's going to make that be 4.3. Okay. 23 is a similar problem. The only difference is it's a sample now. So I'm going to do this one too. I'm going to do it the exact same way. The range is the max minus the min. The mean is X bar because it's a sample. Okay, and we're still using X bar from the calculator. No matter what, we use that. Okay. The variance is S squared this time because it's a sample, and the deviation is just S. So I'm going to put the values into my list. I am going to edit that list or clear it out, go up to the name, press clear, enter. So I've got 12, 15, 23, 15, 13, 17, 22, 17, 14, 18. Okay. Now the range is the max, which is 23, minus the minimum, which looks like it's 12. So 23 minus 12, that's 11. Okay. Now to get the other values, we're going to press stat and we're going to go over to calc. So you have to do the range by hand. Okay. But it's just max minus min. We're going to use number 1. I already have my list 1. By default, they use list 1. That's where my data is. Go down to calculate. Now, X bar is your mean. That is rounded to one decimal, 16.6. So we're good there. Now, variance, S squared, I do not have S squared. I have S though. S is 3.627058802. And I'm going to square that in order to get the variance. So I'm going to say 3.627058802 square. And that gives me, rounded to one decimal, that gives me 13.2. Those fives make that one go up. And the deviation, this is the deviation before I squared it. I just need to round it off. So it's going to be 3.6. Okay. So again, same exact process. I'm going to put square this in order to find variance because they give you sigma. You want a sigma squared up there. They give you S in the calculator. You want it S squared. Okay. All right, y'all. Let's keep it moving. Kind of got a long little set of problems, about 40 of them. 24. Okay. The 5-number summary. So basically, number 24 and 25 are the exact same problems for the most part. So I will probably just do one of these. Literally, they look like almost the exact same data set. Is that the exact same data set? It looks severely close to being the exact same. 388629879969516298298. That is the exact same data set. Wow, I've never seen that happen. So yeah, that's the exact same problem. So on the exam, it would just be one of these. You wouldn't see both of these questions, okay? And again, somehow it's the exact same data set, randomly generated the exact same. So I'm going to work number 24, and I'm not going to worry about number 25 because it's the same problem. So with number 24, we're going to put the data in list 1. So I press stat, edit. Let's go up to the list and press clear, enter, okay? So I put the data in as I see it. 3, 8, 8, 6, 2, 9, 8, 7, 9, 6, 9, 5, 1, 6, 2, 9, 8, 7, 7, 9. Okay, we got 20 value. 20 values. Okay, 20 data values. All right, now let's press the stat key. Let's go over to calc, and we're still rocking with number one variable stats. Go down to calculate, and we're looking for the 5-number summary, the minimum, the Q1, Q2, Q3, and the max. And then we'll do a little sketch. So I'm going to arrow down here because I see the minimum. The minimum is 1. The minimum data value is 1. I see Q1 is 5.5. You do not round these, okay? Keep it exact. Q2, which is the median, put median right there beside that. That's 7. Q3 is 8.5, and then the max is 9. Okay, so we have the 5-number summary. Then we do a sketch of the graph. So basically, if we draw our little short number line, let's say 1, 2, 3, 4, 5, 6, 7, 8, and then let's go 9. Okay, so our minimum is 1. Our max is technically 9. I probably shouldn't put these in yet. I don't think I will. I start off with drawing the box. From Q1 to Q3, I draw my box. So at 5.5, which is right here between 5 and 6, and then at 8.5, which is right here between 8 and 9, I make my bar using those lines. Okay? Then I have Q2 on the inside at 7. So Q1, Q2, Q3, and then I have a whisker that extends from Q3 to my max, and I have a whisker that extends from Q1 to my minimum. Okay, so it has to be D. It has to be D. That is the one that has Q1 at 5.5, Q3 at was 8.5, and then that longer whisker, it's D. Okay. Again, 25 is just like 24, literally. It's the exact same problem. One of those, only one. You should expect only one. You won't see two of those. And I'm sorry. Hope I didn't move that too quickly. Okay. All right, moving on. We're in 2.2 now, looking at correlation. First starting out with a little terminology. When two variables have a positive linear correlation, that means they're both increasing. The dependent increases, so the independent increases. Okay, positive correlation, both going up, both increasing. When it's negative, the dependent will increase, but the independent one will decrease. It will go down. So as X increases, Y decreases. That's when it is a decreasing or a negative correlation. The range of the correlation coefficient R must be somewhere inclusively between -1 and +1. Okay, so that would be C. It can be anywhere from -1 to +1, inclusive. 28, what value of R indicates a strong correlation? Well, you look at the sign when you're talking about direction. When you're looking at, or when you're interested in strength, you focus on the number, the numerical value. So basically just ignore the negative sign. This one is stronger because this one technically is closer to -1 than that one is to +1. So we say R equals -0.927 represents a stronger correlation because if you drop off the negative sign, or in other words, if you take the absolute value of this one is bigger than that one. So that would be A. Okay. Then that gets us to looking at um, regression analysis, trying to find the regression equation, the best line of fit. Okay, here we're looking for the regression equation, the regression model. So when I printed these problems, they tend to print the problems, not the problems, print the data, the x, y values on the other side. So I'm going to put these in, the x's in L1, I'm going to put the y's in L2, and then I'll flip back over. So I'm going to press the stat key, turn it on here, clear that off, press the stat key. You want to edit. You already have something in a list, so let's clear that out. Arrow up to the name, press clear, enter. So in list one, I've got 20, 18, 17, 16, 14, 12, 11, 9. And then in list two, I've got 2.82, 3.38, 2.65, 3.64, 3. Uh-oh, 3.95, okay, enter, 4.32, 3.88, 5.19. Okay, and just double check. So easy to make a mistake when you're typing in decimals. Okay, we're good there. All right, good deal. I'm gonna turn back over here. And now I'm going to get my regression equation. Now, remember, always make sure your diagnostic is turned on. And I will say this when we get to class, before we take the midterm, I will have you to walk through these steps. You see catalog in blue? That's the second function of the 0 key. I need you to press that. I need you to press the second button, 0. That brings us to, in alphabetical order, everything, every app, every operation, everything that's on this calculator in alphabetical order. You want to scroll down till you see diagnostic on, till we see diagnostic on. Okay, there it is. So we're going to press enter there, and then we press enter again to turn it on. It's on now when it says done. Okay, now I am ready to get my regression equation. So I'm just clear that off. I'm going to press stat. I already put the data in. I'm going to go over to calc now. And I am looking for the regression equation, the linear regression equation. So I'm using number 4, linear regression, AX plus B model, where A is the slope and B is the y-intercept. So my list, by default, X is in L1, Y in L2. That's why it's important that I put the values in that order in those lists, because by default, that's what it's going to use. X is as list 1, Y is list 2. Press calculate. So your regression equation is negative, how many decimal points? 2. So it's negative 0.19x plus 6.54. Okay, that is our regression equation. All right, now we want to construct a scatter plot. We're going to put this equation in y equals so that we can get the line. And I can already omit 2 of these. You've got a slope, so therefore your line can't be horizontal. A horizontal line indicates a slope of 0. We do not have a slope of 0, we got a negative slope. So our line should be going down. Okay, so it's not A, omit A. Also, it's not C because this is not a line. Here, it looks like we're playing connect the dots. We've got a bunch of line segments connecting the points. That's not what a best line of fit or a regression equation model does. It actually finds the best line that gets as close or minimizes the distance between the points as much as possible, gets as close to every point possible. Hence the name best line of fit. Okay, it's not perfect, but it's the best. So omit C for sure as well. So it's either B or D. Let's take a look at it on the calculator. So I'm going to put in the equation in y equals. So right here, I'm going to put in, here's my negative. Make sure you use the negative, not the minus. That's the minus. You want to use the negative. Okay, so I'm using negative 0.19. My x key is right here, xt theta n. uh-oh, go back, xt theta n. So I use that key right there. Then I say plus 6.54. All right. Now I also want the calculator to plot the points. Right now, it's only plotting the equation. So to plot the points, I technically need the plot to be turned on. I already have mine on, but let's pretend like it was off. So I'm going to turn it off. All right, so let's say I've got the equation that's going to take care of the line. I want to turn the plot on. So let's press, you see stat plot right there in blue? Let's press second y equals to turn that on. It's already by default using L1 and L2, and it's going to use this little symbol as for my points, this little small box. I just need to turn it on. So it's already telling me that it's going to plot the points. It's going to plot a scatter plot. I just need to turn it on. So I'm going to press enter there, and it's on. And now I can hit graph. And another way that I'll know that the stat plot is on, take a look. That plot 1 is darkened now. Right up above the y equals, that's darkened. And the good thing about it is once it's on, you can leave it on. You'll modify the data when you put the new data set in the list. So it'll plot whatever is in, as long as you keep the stat plot on, it'll plot whatever data is in the list. So I'm going to hit graph. And you might say, well, you just said it'll plot, but I don't see anything. Well, that's because we haven't fit the calculator's window to that particular data set yet. So to do that, press zoom, and then zoom stat or zoom fit will adjust your window so that you now can see the line and the ordered pairs, the data set. So it looks like this graph, and remember you got a pop-out window. It's hard to tell on here, but on the computer you can do a pop-out. Now it looks like this line has only 2 points below and the rest are above. So that's not shown here on B. I've got more than 2 points below the line here. So that would be D. That would be the correct answer. Okay. And then lastly, we just want to predict the y, which is ERA. We want to predict the y when we let x be 5 in this case. When we let x be 10. When we let x be 19. And when we let x be 15. Now, one of these we won't use, okay? We won't predict for one. And that is because it is outside the range of the original x values of the data set. So let's go back over here and look at this data set. Your data ranges from a smallest value, and we're talking about x here, okay? Because remember, we're predicting y given an x. So the given x has to fall within the range. So our data set, our x values range from 9 to 20. Okay, so that means over here on part A, we can't predict for 5. 5 is not within the range of our original data set. So we have to say it is not meaningful to predict for 5 because 5, x equals 5, is well outside the range of the original data. It doesn't have to be an actual x value of the data set. It just needs to be within the range of it, and it is not. So we have to say B. It's not meaningful. Okay? Then for the rest, we literally just plug in, because 10 it falls within the range. We plug in 10 where we see x. So our equation is y equals negative 0.19x plus 6.54. So we're going to say negative 0.19 times 10 plus 6.54. Okay? And that ends up giving us, let's see here, negative 0.19 times 10 plus 6.54. I'm sorry, I didn't put the point. Negative 0.19 times 10 plus 6.54. 4.64. I got 4.64. In the back, they have 4.62. And the reason they have it's a little bit off on the back answer is because they didn't use the rounded values. They didn't use the rounded values, even though they told us to round it. So it will accept this answer, okay? It makes the adjustment for rounding. I don't know why they didn't use the rounded values because I don't know. But anyway, when you plug in 19.19 times 19 plus 6.54, then you'll have negative 0.19 times 15 plus 6.54. And then I think is that all of them? For 10, for 19, yeah, that's all of them. So you'll plug those in, negative 0.19 times 19 plus 6.54, 2.93, and then negative 0.19 times 15 plus 6.54, 3.69. And like I said, in the back, they'll be slightly different because they did not use the rounded A and rounded B value in your equation. But the computer will accept the answers here because rounding is legal. You can round, okay? All right. This is basically another problem just like that one. I'm going to kind of walk you through this one again so that you can recall the steps. Just when you do it enough, you should get it, okay? So I'm going to put the x's in list 1. I'm going to put the y's in list 2. I'm going to get my regression equation, and then I'm going to look at the graph, okay? And then I'll take the regression equation and I'll substitute in each of these x's to predict the y, okay? So starting off, press stat. We're going to edit. We're going to put our x's in list 1. So I'm going to clear out both lists. And we're going to put our y's in list 2. So the x's, we got 150, 170, 120, 130, 80, 180. Then 430, 480, 340, 360, 260, 510. Making sure we double check. Don't want to make any mistakes. Good there. 150, 170, 120, 130, 80. Good. All right. We're ready to work with the data now. Let's press stat, go over to calc. And remember, this is linear regression. So let me go back here. I feel like I went too fast. Press the stat key, go over to calc, and we're using number 4, linear regression, because it says find the regression line. So linear regression. All right. By default, X list is L1, Y list is L2. So I'm just pressing enter again and again until I get down here to calculate. So I press enter one more time. So my slope is 2.54. We're told to round to 3 decimals. So 2.554. I'm sorry, 3 decimals, 2.554. And my B, rounding that to 3 decimals, 43.416. Okay. All right. Let's press now the y equals to put the equation in y equals so that we can see the graph. So I press y equals. I still have the same equation from last time, so I'm going to press clear, and I'm going to enter this in. 2.554, and I want you to press the xt theta key. That gives me my variable x. And then I say plus 43.416. Okay. Trying to get it out the glare here. All right. Now, I already have the plot turned on. Okay. I don't have to mess with that at all. The reason is because I already changed my list to be this new data set. So the plot being turned on, it will plot this data set. I just left it on from before and I already edited the list. So I just need to press graph, And like right now, I don't see it because my window has not been adjusted for this data yet. So we press zoom and then we go down to stat, and now we'll be able to see it. Our slope was positive, so notice that our line is going up. So there are two that I can omit right away because the line is going in the wrong direction. This is a positive slope, so my line should be going upward. So omit B and omit C. It's either A or D. Let's see which one. Now, this is going to be kind of harder to tell on here. I think I can see though that extra dot right there on D, I don't have it on my image. So the graph, the correct graph in this case would be A. And again, when you're on the computer, use the little pop-out window to make it bigger and you can see it better. But I usually just count the dots, how many are below or above the line, and match it. Okay, but remember that if the slope is positive, your line can't be going down. That's why we omitted B and C right from the jump. Now, the last part here is to predict the value of y given each of these x values. Now, your x's range, x values range from 80, the smallest value of 80 to 180. Okay, so we can predict for 180. 180 is within that range. So you would basically have y equals 2.554 times 180. It's 2.554x. The x is 180 plus 43.416. So A ends up being C, ends up being C here in this case when you plug that in. For part B, we're predicting when x is equal to 100. 100 is within that range. So y equals 2.554 times 100 plus 43.416. And so that ends up being C. Okay. For part C, let x be 140. 140 is within that range. So 2.554 times 140 plus 43.416. That gives us A. And then lastly, you can't predict for the 210 because it's outside of the range. Our data range from 80 to 180. 210 is outside of that range. So we have to say not meaningful. And you got to be careful with this one because the actual answer is present also. If you were to plug that in, you would actually see one of these answers. Don't make the mistake of choosing it because you have to pay attention. 210 is not within that range of the original data set. So no matter what answer I get when I calculate it, it's not meaningful. Okay? All right. There's one more question related to correlation and regression, and that's this one. It says use the scatter plot and what type of determine or what type of correlation does the data show? So with this one, it looks pretty strong. It looks, these dots, especially right up in here, are very tight, close together, appearing to form some sort of line. And then you got a couple that are kind of scattered a little bit outward there, but that is still a really strong positive correlation. Okay, so there appears to be a strong positive correlation. So right away, I am omitting C and I'm omitting D because the points are going upward. So it's either A or B. Let's read A. There appears to be a strong positive linear correlation. As the years of experience of the registered nurses increase, salaries tend to increase. Yeah. So as years increase, as we go outward, the salaries are increasing as well. That's what a positive correlation does. Dependent variable increases, independent variable increases. Okay. And then the rest of these are getting us into probability, basically. We have a few questions here that were at the very end of 2.2, and then we get into 3.1, the first part of 3.1. So here on part, or number 32, it says identify the sample space of the probability experiment and determine the number of outcomes in the sample space. So here, the experiment is guessing the first digit in the price of a car, okay? Well, if you're talking about that first digit can range within the first few digits of the real number set. So that first digit could be a 1, a 2, a 3, single digit. We're talking about a first digit, so we're talking about a single digit, 1 through 9. It can range anywhere from 1 through 9. You could have a car that's 17,000 or 90,000, 1 through 9. So the sample space is just what I wrote here, 1, 2, 8, 9. And then the number of outcomes you count, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them, okay? 33, determine the number of outcomes in the event. Decide whether the event is simple or not. You randomly select one card from a standard deck of 52 playing cards. Event B is selecting a club. Okay, in the standard deck, remember I will give you the fact sheets and it will have the deck of cards with it, okay? So when you're dealing with the standard deck of cards, there are 4 suits. Clubs are a suit. So if there are 4 suits, then that means there are 52 cards to split or divide among 4 suits. So there are 13 cards each in each suit. So there are 13 clubs, 13 cards that are clubs. Okay? 2 of clubs, 3 of clubs, 4 of clubs. Okay? There are 13 cards that satisfy that event. So therefore, there's more than one outcome. Okay? So therefore, it's not simple. So is the event simple? We say no, because event B has more than one outcome. Okay? Number 34, a restaurant offers a $12 dinner special that has 4 choices for an appetizer, 11 choices for an entree, and 3 choices for a dessert. You're trying to figure out all the different meals that you can create if you choose one appetizer, one entree, and one dessert. That is the principle of counting, where you just multiply the different ways you can choose an appetizer, an entree, and a dessert. So 4 times 11 times 3. We have 132 different ways that we can form this particular meal. Okay. All right, 35. Here it says the frequency distribution to the right shows the number of voters according to age. Consider the event below. Can it be considered unusual? A voter chosen at random is between 25 and 34. So 25 and 34 right there. And it is cut off. Doggone it. Let's see. I can figure out what that amount was. So basically what happened is that, again, the table was cut off. When you print this, it made the print too big and it cut the table off. But what's happening is there's a frequency for each of these, and you'll first get the total frequency, and you'll take the frequency of the class 25 to 40 to 34, and you divide it by the total frequency. And if that probability is less than 0.05, it's considered unusual. If a probability is less than 5% or 0.05, then that event is considered close to zero and unusual. Okay. So we would say this one, it is unusual. The answer ends up being yes, the probability of the event is close to zero, which is anything less than 0.05. 36 lists an example of two events that are independent, lists an example of two events that are dependent. And we did work through these problems in class last week. But remember, independent events are two events that have no effect on each other. Okay, one occurring has no effect on the other. And dependent, of course, is the opposite. So in part A, we're looking for the two that are independent. So a father having hazel eyes and a daughter having hazel eyes, those I would say are dependent because typically eye color comes from from the father. It's a recessive gene. It comes from the father. So it's likely that she has hazel eyes because of her dad. Okay. B, selecting a queen from a standard deck, not replacing it right away. If you don't replace it, that means your probability for the second card is already going to be affected by the fact that you already pulled a queen because you didn't put that first one back. So those are not independent either. C, not putting money in a parking meter and getting a parking ticket. Yeah, I mean, if you did not put money in the parking meter, the higher the chance that you'll get a ticket. You can't get a ticket if you, I mean, it's possible that you can get away if there's no patrolman. You can get away with not getting a ticket, but I guarantee if you didn't put money in there, that's the reason you got it. So those are dependent. Uh, so D has to be the answer, rolling a die twice. And die just means a single dice, one dice. So if you roll that die once, whatever you got on that first roll has no effect on when you roll the second time. So those are the independent ones. Okay. And then for part B, all of these are independent except for one choice, which are the ones we're looking for. We're trying to figure out which ones are dependent this time. So A says tossing a coin and getting ahead, and then rolling a six-sided die and obtaining a six. Well, those are two separate entities. Okay, I could have the coin in one hand, I could have the die in the other. What I got over here with the coin has no effect on what I get on the die. So those are independent. B, drawing one card from a standard deck, not replacing it, and then selecting another card. There you have it. Those are the dependent events because you did not put the card back before you selected the second card. C, those, we'll just go through the rest. C, those are independent because you're just rolling a die twice. Whatever you get on the first roll has no effect on the second roll. They're independent rolls. And then D, selecting a ball number 1 through 12 from a bin, replacing it. It says you're putting it back. So that means those are independent selections or pulls from the bin. Those are independent because you still have all 12 to choose from. Okay? So that would be B. Those would be the dependent events. All right, number 37, we did this one in class also. It says, according to a study, 88% of K through 12 schools or districts in a county use digital content such as ebooks, audiobooks, and digital, I don't know, digital learning or something. So then it says, of these 88%, 11 out of 20 use digital content as part of their curriculum. So first off, it says 88% of all the schools use digital content. And then it says of the schools that use it, of the 88%, 11 out of 20 use it specifically for curriculum. Okay. So we want to find the probability that a randomly selected school uses digital content and uses it as part of their curriculum. So this is where we take the 88% times the 11 out of 20. We make that 88% 0.88. That is the percent or the probability that a school uses digital content. And then this is of those that use digital content, these many or this many use it as part of their curriculum. So we multiply because it says the word and. Uses digital content and uses it as part of their curriculum. So this would be a multiplication rule, use digital content and part curriculum. So because it says and, that is the multiplication rule where we multiply. Okay. So 0.88 times 11 out of 20, 0.484. Okay. Moving on, moving on. All right. We've got this problem here, and we did look at it in class as well, but I will walk through it as if we haven't seen it. And then we got these last two here. So I'm definitely going to need some paper for this one. And in this one, we've got a table that we're using to work through or answer the questions. So it says the accompanying table shows the numbers of male and female students in a certain region who received bachelor's degrees in a certain field in a recent year. A student is selected at random. Find the probability of each event listed in parts A through C. Okay. So part A says the student that we're selecting at random, the student is male or received a degree in field. So we're talking about male or received a degree in field. So let's just take a quick look at this table. You've got right here in this bottom right-hand corner, that is your total sample space. Because remember, in probability, we consider our total sample space as like it's our total population. Okay. So of this 1,745,811, 796 and some change were males, 949 and some change were females. Of the males, some earned a degree in field, some earned a degree outfield to give us that total. Of the females, some earned a degree in field, some earned a degree outside of field to give us the total females. So you got rows, okay, divided, showing male total at the end of that row, female total at the end of that row. Okay, and then you got columns talking about degree infield versus degree outfield. And at the bottom of each column, the total number of students who earn a degree in field, regardless of gender. And here, the total number of students who earned a degree outside of field, regardless of gender. So keep that in mind that when we are finding these probabilities, this will be your denominator each time on this problem. This total sample space number will be your denominator for every problem or every one of these parts here. So let's look at part A. We're trying to find, and I'll refer to the table when I need to. For part A, we're trying to find the probability that the student selected is male or in-field degree. So I'm going to put male or in-field, okay? Now, what I have to do when I see the word or, I recognize it is the addition rule. So I have to determine, are these events mutually exclusive or not? So are they mutually exclusive? Let's take a look at our table. So here we've got males, that's a row, okay? And in field, degrees in field, that's a column. Anytime your row and your column are intersecting each other, then you do not have mutually exclusive events. They overlap. So are they mutually exclusive? We say no. So when we get ready to apply the addition rule, we have to do the extended addition rule. We have to say the probability of selecting a male plus the probability of selecting a student who earned a degree in field minus the probability of selecting a student who is male and earned a degree in field. Okay, so let's get the total males. All right, so we're looking for the probability of selecting a male in general, regardless of degree in field or outfield, male in general. We've got 796, 530 out of our total sample space, which is the 1,745, 811. Okay, then we're going to say plus the probability of selecting a student who earned a degree in field. So earned a degree in field, that would be this total amount right here, regardless of gender, earned a degree in field. That is 303,586 out of that same sample space, 1,745, 811. And then from that, we're going to subtract the total number of students who are both male and earned a degree in field. So that's where they overlap. The male row in field column right there. There were 172,402 who are male and earned a degree in field. So we have to subtract that because that amount, if you think about it, that amount was included in this total for degrees in field, and it was included in the total for males right here. It's in this column and it's in this row. So we have to subtract that. And again, out of that denominator, 1,745,811. So you're going to keep that denominator. And you're going to add these two here and then subtract that third value. So 796,530 plus 303,586 minus 172,402. And we get 927,714. 927,714. And then we're going to divide that by our total sample. Oh, I didn't mean to do that. Let me put that back. Okay. Then we're going to divide that by the 1745811. And we get 0.531. Okay. Okay. Part B, it says find the probability that the student is female or received a degree outside of the field. So part B, I may have to zoom out a little bit here. We're looking for female or outfield, degree outfield. So I'm just going to put outfield. So again, take a look at your connecting word. It's or, which indicates addition rule. When it's and, it indicates multiplication. But when it's or, it's addition rule. And when you have the addition rule, the question of exclusivity comes into play. Are they mutually exclusive? And in this case, if you have a row intersecting a column, they are not. So females is a row, it's the second row. Outfield, degrees outfield is a column. They intersect each other. So are they mutually exclusive? We say no. So we're going to find the probability of selecting a female student plus the probability of selecting a student who earned a degree outfield minus the probability of selecting a student who is female and earned a degree outfield. Okay. So probability of selecting a female student. Now this is female in general, regardless of the degree that they earn, just females in general. Total females is 949,281. 949,281. And that is still out of that total same sample space, 1,745,811. Then we look at outside field, degree outside of field. That total at the bottom of that column is 1,000,000. 442,225 out of the total sample space, 1,745,811. Now, that 1,000,004 and some change, that included both of these values together, the number of male students who earned a degree outside of field and the females who earned a degree outside of field. That's where we got that amount. Okay, now look at the female row. This is the total number of females. That amount, that total number, is counting the number of females who earned a degree in field and outfield. So if you think about it, this number right here was counted twice. It was counted in this total and this total. So we have to subtract that. So we have to say minus 818,097 out of 1,745,811. So we end up keeping that denominator just like we did before and combining the tops all together, the numerators all together. I'm going to scoot this up a bit. Let's see what we get. 949,281 plus 144,2225 minus 818,097. So we get 157,3409, and we're going to divide that by 1,745,811.901. 0.901. That's supposed to be one there. Sorry. You rewrite it 0.901. Okay. All right. One last part here on part C. It says find the probability that the student is not female or they earned a degree outfield. Let me put outfield. So in this case, if they're not female, we have to just conclude male. Okay, we have two options, female, male. So in this case, we're going to be looking at basically just not female. Then that means we're talking about male or degree outfield. Okay, male or degree outfield. So instead of putting not female, let's just change that to what we're focusing on. Okay. So again, this is or. So the question of exclusivity comes into play. Are these two events mutually exclusive or not? So male is again a row. Outfield, degree outfield is a column. They intersect each other. So therefore they overlap. So therefore they are not mutually exclusive. So to get this probability, I want to find, let me put it again, male or outfield. I want to find the probability of selecting a male in general, plus the probability of selecting a student who earned a degree outfield, minus the probability of selecting a student who is male and earned a degree outfield. Okay? All right, and we are almost done. It's been a kind of a lengthy video here. So probability of selecting a student that is male, it may help if I fold this down. Let's do that so that I can see the table still. Let's do that. Okay. So here we go. Part C now. I can see the table and I'm working part C. All right. So probability of selecting a male student. Males, this row here, total number of males, 796,530. 796,530 out of 1,745,811. Okay. That's again always your denominator for this problem. Then the probability of selecting a student who earned a degree outside of field. Well, outside of field, regardless of gender, outside of field is that 1,442,225 out of the 1,745,811. Okay. Then we're going to subtract from that this value where they overlap. So we have the males row right here that includes these two amounts that are added together to get this total. And then we have the outfield column here, these two values that add together to give us this total. That value right here has been counted in the male total and it has been counted in the outfield total. We have to subtract that overlap. When you double count that one, that amount, then what you're saying is it's more important than all the others, and we can't do that. In probability, every outcome is equally likely. So we have to subtract that. So subtract 624, 128 out of that total sample space, 1745, 811. So again, you would keep that denominator, add these two together, and then subtract that one. So I will show that 796,530 plus 144,2225 minus 624,128. So we get 161,4627 out of 174,5811. And let's see what that gives us. So I'm going to divide that by 1745811. I get approximately 0.925. Okay. All right. Last couple problems here. 2 more to go and we will be done. Okay. And let me just kind of put this back on here. Try to zoom out so you can see all the parts. A, B, and C. Practice on this one, okay? This problem will show up on the midterm, without a doubt. Okay? All right. And then lastly, you've got 39 and 40, where you just have to determine how many different ways you can permutate 50 objects 2 at a time. Or in other words, when it's a permutation, because that's a P there, that means permutating. Order matters when it's a permutation. So in other words, you got 50 objects and you want to figure out how many different ways you can order them, taking them 2 at a time. So this is NPR, where the N is 50 and the R is 2. So we're going to tell the calculator that N is 50. So I'm going to type 50 on my calculator first. Then I want you to find or press the math, and this is on the fact sheet how to pull this up. To get to this key, you press math, you scroll over to PRB or PROB, depends on the calculator, and then you're going to select number 2, the NPR. Okay, so we select number 2 there. Now it puts it in this subtext. You can see here, because I have the newer operating system. The old operating system may show it like this, 50 NPR, and then you'll type 2. So it may have the numbers out big still, but typing 50 first, you're still telling the calculator that the N is 50 and the R, you're going to type 2 next, the R is 2. Here, it puts it in the subtext for me. So 50 objects taken 2 at a time there are 2,450 different ways. Okay. So permutation means order matters. A combination, order does not matter. So in this case, this is in choose R. When it's a C, we don't say combinates, we say choose. In choose R. So N is 22. There are 22 objects. We want to figure out how many different ways we can form groups of 3 of them at a time. 22 objects, choosing 3 of them at a time. So 22 and choose R3. So that's literally what I'm going to type in my calculator. 22. Then I press math. I go over to PROB, and it's number 3 on my calculator. It'll be 2 or 3 on your calculator. NPR is 2, NCR is 3. And again, if you have the old operating system, they may shorten the probability. They may just have PRB. So I go down to number 3. I already told the calculator what the N was. Now I have to tell it what the R is. So there are 1,540 different ways that I can choose 3 objects, that I can take 3 objects at a time, given that I have 22 total. Excuse me. Okay. And again, we get to this icon or this notation by pressing math. Go over to PROB or PRB, depending upon your calculator. And then you'll choose, this case, I believe it was number 3, the NCR. Okay. All right. That is it for the review. A little bit lengthy, but remember this acts as your test bank. So if you can work through this, you should do great on the midterm. All right. Happy studying. Good luck. See you all soon.